was a square plus b square plus twice ab cos t whole half power into dt. This was the value of lemma. On length of the ellipse we are calculating. And here we find that ds upon dt whole square is equal to, we have obtained now a square plus b square, because cos sin square t plus cos square t is 1, sin square t plus cos square t is 1, minus twice ab into cos 2t. Okay, so ds upon dt into dt, the length of this will be square root of this whole value. So this is giving us ds upon dt, therefore is equal to square root of a square plus b square minus twice ab cos 2t. Angle is here is twice t. Okay, now let us talk that what is the length of the ellipse. The value of ds upon dt. Therefore, length of the ellipse will be. Let me change the marker here. Let me change the marker. Length of the ellipse here will be. Okay. Now, if I find out the limit for the one of the parts of the. Okay. Now, if I find out length of the whole ellipse, therefore length of the ellipse, now 1/4 of the ellipse, let me find out length. So for 1/4 of the length, because ellipse we know this is the ellipse here. Now from 1/4 of ellipse is 0 to theta equal to here 0 or angle whatever t we have taken here. Where t is 0, here t equal to pi by 2. So 1/4 into 4 times. Therefore, length of the ellipse 1/4 of it. 1/4 into 4. 4 into 1/4 length. It will be 4 times 0 to pi by 2. So this is 0 to pi by 2. T value is. Now this is ds upon dt into dt. It will give us 4 0 to pi by 2. What it gives us? This is a square under root a square plus b square minus twice ab cos 2t. Okay, now if I change the limit 0 to pi 2t, let me put 2t equal to t. So the limit will be 0 to pi here, because at pi by 2. Okay, if I put 2t equal to theta or any angle, then the limit will be twice of this. So this 0 to pi will come out then. If I put t equal to, change that into the same form, then what it will be? But it is minus sign here, so cos 2t is minus with minus sign. It will be then positive. So cos 2t, if I take the, now let me put the limit here. So 4 times is the total length of the ellipse. Total length of the ellipse. Total length of the ellipse is equal to 4 times 0 to pi by 2 under the square root a square plus b square minus twice ab into cos twice t whole power 1.2 into dt. Okay, now this marker is creating a problem. Okay, sorry. This is the value here. I'm sorry. So that is giving us the value of this question. The final value of this question will be, okay, if I put here 2t equal to something. Okay, now substituting here, let 2t equal to if I put twice t something, you take it as pi minus u. Pi minus u I have taken 2t equal to. Therefore, what are the limits here? So the upper limit will be, so in limits will be changed into u when t is 2t equal to this. Okay, so limits, let me change your 2 into dt is equal to du only, sorry, du. Let me convert them into this. This is du here, sorry, minus du. Limit will be minus du here, alright, minus du, okay, minus du, or dt equal to therefore minus du upon 2. This is the value of dt here, okay, that we will take, and minus du, and then 2t is pi minus u, and if I upper limit, if I put at t equal to pi by 2 here, so at limits let me change. So limits let me change at t is equal to pi by 2, u is equal to, u here is pi minus 2t. So u is equal to pi minus 2t. Reason is this, u is equal to pi minus 2t and t is pi by 2, so it is pi minus pi 0. So therefore u is equal to, let me write here. Let me write here. So u is equal to pi minus, sorry, this is pi minus 2t. Pi minus 2t. At t equal to pi by 2, u is equal to pi minus pi means 0, and at t equal to 0, u is equal to pi, because this t is 0, so u is equal to pi. So I'm sorry, pi. So limits are reverse, but minus sign is there. It is therefore limit of that. Let me take capital S here. It was 4 times. It was, let me first write that value, same value, 0 to pi by 2. It was under the square root a square plus b square minus twice ab. It was cos 2t. Okay, so limit we have substituted here, twice ab into cos 2t into half power dt. What is converted it into? It converted into minus sign. Limits is now pi to 0. Try to understand with minus sign. And this is dt upon, it is a square plus b square minus twice ab into cos of pi minus u. But cos pi minus theta is negative theta. It will be positive here, so it will be cos u into dt or du upon 2 minus sign I have taken outside. It is negative sign, so it will be, limit will be changed to the twice 0 to pi here. Now this is cos pi minus theta. We know that cos pi minus theta is equal to minus cos theta. Inside this will be cos u. So it is a square plus b square plus twice ab into cos u into du. What do we see here? This is the same length of the ellipse is equal to lemma cone. Length of the lemma cone is a similar type. Here variable is u, no problem, but their variable was t here, sorry, that was theta. So theta variable was there. The same type of length, which was length of the lemma cone. Length of the lemma cone was, so length of the lemma cone, which was twice 0 to pi, it was 0 to pi, within bracket a square plus b square plus twice ab cos theta, it was plus twice ab, yeah, plus twice ab cos theta half power into d theta. It was the value of length of the lemma cone. And length of the ellipse, here we have obtained length of the ellipse. We have obtained here twice, again it is 0 to pi, You do pi again a square plus b square plus twice ab into cos u into du. So only variable is different, but length is same. Okay. So these are this we have to prove here in question number 7. Question number 7 we have proved here that yes, the length of the whole length of the lemma cone where a is greater than b is equal to that of an ellipse, semi-axes of which are equal in length to the maximum and minimum radii vectors of the lemma cone. So minimum and maximum radii vectors of lemma cone we calculated. It was a plus b at theta equal to 0, and at theta equal to pi it was a minus b. We took that a minus b and a plus b as the semi-axis and minor semi-axis or major semi-axis. Major semi-axis was a plus b and minor axis was a minus b. Then we converted that into Cartesian form. Cartesian form. Okay, so that was parametric form. So x we took as a plus b cos t, and y we took as a minus b sin t. Then we converted the whole value. Okay, and we found out then ds upon dt, and ds upon dt we calculated from dx upon dt whole square or dy upon dt whole square, and that has given us length of the ellipse. The same type of length of the ellipse has obtained. The length of the ellipse, we see the same formula, same length is obtained. Okay, only variable is different, so it doesn't matter. But length of the magnitude of the length is same. Okay, so hence proved. This is the question. 7th question is very good question here. Hence proved that length of the lemma cone is equal to length of the ellipse, the semi-axis and minor axis. The semi-axis of which ellipse are maximum and minimum value of the lemma cone or radius vector of the lemma cone. Maximum value of radius vector of the lemma cone and minimum value of the radius vector of the lemma cone. They are the semi-axis of ellipse. That is the condition given to us. From there we have obtained that yes, this is the point here. Now let me take question number 8. Okay, now up to this question. Now question number 8, what does it say? Question number 8, let me take here. Question number 8 says, okay, prove that the perimeter of the lemma cone, okay, are equal to a plus b. So here we have to find out a plus b cos theta, length of the lemma cone. This is the equation of the lemma cone here. Again, the same kind of formula we have to apply. Is the lemma cone here. Okay, so I'm sorry, this is a plus b, this is a minus b here, and here, I'm sorry, figure is not proper one, and here it is a plus 1.2b, this is a plus b. At this theta equal to 0, here theta equal to pi, at theta equal to pi it is a minus b, and at theta equal to 0 it is a plus b, maximum value, minimum value. Okay, and this is under arc here, this is a minus 1.2b length of this. Okay, so this is the lemma cone. The length of this we have to find out. So that is simple. We have just calculated in question number 7 here. So that kind of length was there. Okay, so that length to the maximum and minimum value. Prove that. Okay, prove here in the 8th question we have prove that the perimeter of the lemma cone are equal to this b upon a is small is approximately 2 pi theta into 1 plus 1.4 b square upon a square. Okay, so we have to equate this equal to this value. This we have to further solve. Okay, so after 5 minutes take, I'll just do this. So at the moment I'm busy here. Sorry.